Right. Okay. So let's start from the revised exercise. Right. Okay. Now let's quickly do this one. Once, as you can see here, we have started from aldehyde. Then we know that we have a green out region. So therefore, you have to choose the green out region that we have added here. So benzene is newly added to the compound. MgBr is newly added for the compound. So therefore, we can say that benzene magnesium bromide, right, is the green out region that we have added. And hereafter, you know that what we have to do, we have to do the hydrolysis reaction in this way. Okay. So this is actually the first reaction that we learn, aldehyde ketone with Grignard region, right? Now look at the second reaction. Second reaction is Cl has been converted into OH, right? So what we have to do? So you can add here aqueous KOH, aqueous potassium hydroxide, in order to convert Cl into OH. And then look at, you can see here, this is CH3Br, and you can see that an additional group is there like this, right? CH3, C triple bond CH. So how we can form this one? So sodium derivative of alkynes are reacting with alkyl halides in order to form this kind of compound. So therefore, we can say that the compound that we have added is sodium derivative of an alkyne like this. And here, what is this? So we can say that this is Fiedel-Crafts A side, isn't it? We are adding here. We have acid halide CH3C double bond Br. So we are adding benzene ring, anhydrous aluminum trichloride. You can see that this is a Fiedel-Crafts acylation reaction, and we have obtained this kind of a product. And look at this one. So this is actually carboxylic acid is reacting with alcohol in the presence of cancerous sulfuric, and it is heated, right? So this is actually esterification, right? If you can remember, this is the esterification reaction. So we can obtain the product like this: CH3, C double bond O, CH2, CH3 like this. So this is the product. Number 5. Okay. Quickly complete these things. Revise all the reactions that we learn up to now. Even in the theories, we have discussed many reactions by now. So therefore, you can revise all the reactions we learned. Number 6. There are two compounds. They are connecting together and producing this kind of an ester. O C double bond O CH2CH3 in this way, right? So this is also ester. Now remember, in the esterification, I told you that there are two methods to form esters, right? So one of the methods that we learned, carboxylic acids are reacting with alcohols to produce esters. And the second method is acid halides are reacting with alcohols in order to produce esters. So therefore, here we didn't add here consider sulfuric or anything. So therefore, we can say that the compounds that we have added are acid halide and an alcohol, right? Because we didn't add here any kind of a catalyst. So therefore, you can separate these two into acid halide and alcohol. So we can say that the alcohol means we have added phenol, right? When OH group is directly connected to the benzene ring, that is known as phenol. And what is the acid halide then? CH3, CH2, C double bond O C. Remember, students, I told you that phenol is not reacting with carboxylic acids to produce esters, right? Even in this catalyst medium, phenol is not reacting with carboxylic acid to produce esters. Phenols are only reacting with acid halides in order to produce esters. Number 6. Quickly complete this one. Let's revise all the reactions we learned up to now. 7th one. So we can consider we have this kind of an aldehyde, CH3 C double bond OH. And just imagine we're adding HCl. Can I remember? Right? Aldehyde ketones are reacting with HCl. Then what are the products? We know that hydrogen is going towards this oxygen. Cyanide group is connecting to this carbon. So therefore, we have cyanohydrine in this way. OH, HCN. Okay, so this is also one of the reactions we learned. Number 8. We have an acid halide. For this one, we are adding CH3, CH2, NH2. Okay. So how this reaction will take place here? Remember, students, acid halides are reacting with amines. CH3, C double bond O Cl. This is an acid halide. This is reacting with this amine, primary amine, in this way, CH2, CH3. Hydrogen is eliminating with chlorine. Then it is producing an amide, CH3, C double bond O, NH, CH2, CH2. Right? So this kind of an amide is produced from this way. Okay. How about number 9? Right, look at this one. CH3CH2Br, ethyl bromide. This is reacting with excess methylamine. Okay. So when we add excess methylamine, what will happen? We know that if you don't add excess here, I told you when we discuss about these reactions, amines, primary amines or ammonia reacting with alkyl halides. At that case, we know that if you don't add excess amine, this is going for a quaternary ammonium salt. Can you remember quaternary ammonium salt? So therefore, in order to prevent from that, we have to add excess amount of amino ammonia that we are adding. So therefore, we can say that here simply hydrogen is eliminating with one of the hydrogen is eliminated with the bromine atom in the alkyl halide. Then it is producing CH3NH, CH2CH. This kind of a product. Okay, number 9. Number 10. Number 10 is very easy. Let me consider chlorobenzene. We are adding magnesium diether to produce Grignard region, isn't it? Alkyl halides are reacting with magnesium diether in order to produce Grignard region, MgCl. Right? Very easy reaction that we learn. Number 10. Quickly complete the reactions. Revise the reactions you learn. Number 11, CH3, CH2OH. Number 12. Number 13. So these are the reactions of terminal acidic hydrogen in alkynes. Number 14. Alkyl halides are reacting with alcoholic KOH. So here I'm expecting from you major product and the minor product both. Major product, minor product. Okay. So what about the 11th one? We're adding PCl5. When we add PCl5 for the alcohol, it's producing alkyl halide. When we're adding PCl5 for the carboxylic acid, it's producing acid halide, right? So this is actually hydration of alkynes, right? Hydration of alkynes. I told you that in this kind of a molecule, oxygen and two hydrogens are connecting to the triple bond carbon atoms, right? So here we know that the rule, the rich gets richer. Okay? Always when hydrogens are connecting to double bond or triple bond carbon atoms, it is connecting to the carbon atoms who is already rich with hydrogen. So therefore we can say that two hydrogens are going for this carbon atom and oxygen is going for this one. And then we can say that CH3, C double bond O, CH3 acetone is the product. Now we are adding these four compounds. We have discussed about these things. So when we add sodium for this one, what will happen? CH3, C triple bond, C minus Na plus. So hydrogen gas is liberated from this reaction. So when we add sodamide for this one, again the sodium derivative is produced and ammonia gas is liberated as a product. When we add ammonia copper chloride, ammonia cuprous chloride, what will happen? So instead of hydrogen, copper is connecting there. So this is a brown color precipitate. And here we can say that instead of hydrogen, silver is connecting here. So this is actually silver. We can say that this is white color precipitate. Okay. So these are the reactions that we learn under the terminal acidic hydrogen of alkynes, right? Now let's go for this one, alcoholic KOH, right? This is an elimination reaction. Chlorine is eliminating with the hydrogens from the nearest carbon atom, right? So here, students, we know that we have to apply Zaitsev rule. So the Zaitsev rule says that the poor gets poorer, right? So when you consider this carbon atom, who is poor with hydrogen atoms, left hand side or right hand side one? So we can say that this is the carbon atom which is connected to chlorine, and these are the two neighboring carbon atoms. So one is rich with hydrogen, the other one is poor with hydrogen. So therefore, chlorine is eliminating with the hydrogen atom who is already poor number of hydrogen. So therefore, this is the carbon atom who is poor with hydrogens among the neighboring carbon atoms. So therefore, one of the hydrogens will be eliminating from here, chlorine is eliminating here. Then we can obtain the major product like this CH3, CH, double bond CH, CH3. So what is the minor product? So minor product is actually where that compound is not following the Zaitsev rule, right? I told you that when the elimination is taking place, hydrogen should always eliminate from the carbon atom who is having poor number of hydrogen atoms. So therefore, when it is unfollowing that rule, hydrogen is eliminating with the carbon who is rich with hydrogen. So therefore, we can remove hydrogen from the left hand side carbon. So therefore, CH2 double bond CH, CH2, CH2. So this is the minor product of the reaction. Okay. Number 14, it's like this. Right, okay, are we done? Let's move to the next reaction. Number 15, CH3, CH2. Bromine atoms are connected here, CH3. We are adding alcoholic KOH for this. Number 16. CH3, CH2, MgBr, Grignard region, is reacted with this alkyne, CH3, triple bond H. In this, number 16. Number 17, we have alcohol, CH3, CH2OH. And we are adding acidic KMnO4 and PCC. Then what other products? Number 18, we have secondary alcohol. So these are oxidation of alcohols, acidic CrO3. Number 19, can you remember dehydration of alcohols? We are adding concentrated sulfuric and heat. Dehydration of sulfur. Number 20. CH3CH2Cl. Okay. No, this is 90. So let's quickly complete this one. Number 15, alcoholic KOH. So this is actually geminal dihalide, right? That means two halogen atoms are connected to the same carbon atom. So therefore, hydrogen eliminating with the hydrogen eliminated from the carbon atom who is poor with hydrogen. So therefore, we have to choose left-hand side carbon atom. So therefore, CH3, C triple bond, C, CH. Right. So this is actually acidic hydrogen of acidic terminal hydrogen of alkyne is reacting with the Grignard region. So in this case, we know that hydrogen is eliminating with the alkyl group here. Then it is producing ethane CH3 CH3, and the byproduct is this kind of a compound. So alcohol, this is the alcohol, and we are adding acidic KMnO4 and PCC. So what are the products? When we add acidic KMnO4, it's going for the carboxylic acid, CH3 C double bond OH. So when we add PCC, what will happen? It will convert into this kind of an aldehyde in this, right? We can stop this one at the aldehyde stage by adding PCC. Acidic CrO3. So if it is a secondary alcohol, remember students, always we can end up with a ketone. No issue. Consider sulfuric and heat is added. So therefore OH is eliminating with hydrogen here. CH3, CH double bond CH2 in this. Number 19. Yeah, we can write down that one as a minor product. That means having dihalide. Bromine is eliminating here with this hydrogen. Bromine is eliminating with this hydrogen. So you can write down that one as a minor product. It is considered as a minor product, yes. Shall we move to the 20th one? Number 20. So we have this kind of a alkene. Can you remember? Addition reaction of alkenes, right? Hydrogen nickel, Br2CCl4, HBr, HBr in the peroxide medium, diluted sulfuric, bromine water, OH minus KMnO4. Okay. Complete the reactions. So when we add hydrogen nickel, CH3, CH2, CH3, propane is produced. Right? Double bond is breaking and two hydrogens are connecting there. And here bromine, so bromine atom here and CH2Br. So HBr is added. So therefore CH3, CH, Br. HBr in the peroxide medium, we can say that CH3, CH2, CH2Br. Right? So it's unfollowing the Markovnikov rule. I told you that always hydrogen should be added to the carbon atom who is rich with hydrogen. But in the peroxide medium, it won't happen. So diluted sulfuric. So what will happen? So hydrogen is connecting along with OH. So therefore alcohol is produced. Remember students, this reaction can be done by adding concentrated sulfuric followed by hydrolysis reaction. Okay, so therefore both the methods are correct. This diluted sulfuric cannot be added to produce ethanol. Okay, under the theories I told you. And then Br2OH. So we can say that CH. This is OH, and here we can see CH2Br. OH is acting as the negative one, and Br is acting as the positive one. So in OH minus KMnO4, we can say that two OH groups are connected to the double bond carbon atoms in this way. Okay. Right. Okay. So this is actually a quick revise of the reactions we learned up to now in the organic reaction practice sessions. Okay. The reason we are adding CCl4 for Br2 is actually Br2 is nicely dissolved in these kind of non-polar compounds. Because can you remember, like dissolves like non-polar compounds are dissolving in non-polar compounds well. So therefore Br2, so without going out, right? Sometimes Br2 can go out as a vapor or something like that. So therefore we can keep the Br2 in CCl4 medium nicely rather than taking a Br2 aqueous solution. Okay, that's why we are adding Br2 CCl. Okay. Right. Okay. Now, students, we are going to discuss one of the very important reactions in our syllabus, right? So these are known as actually self-condensation reactions. Okay. So write down carbon increasing reactions number 9. Carbon increasing reactions number 9. Carbon increasing reactions number 9. Self-condensation. Self-condensation reactions of aldehydes and ketones. Self-condensation reactions of aldehydes and ketones. So these reactions actually belongs to aldehydes and ketones. These are known as self-condensation, right? Self-condensation means the molecule is adding to the same type of a molecule, condensation, right, of aldehydes and ketones. So some actually refer this one as aldol condensation, but this is not only for the aldehydes. So we can say that is valid for the ketones as well, right? So we can say ketone condensation is also correct. So, but the common name that we can use is self-condensation, right? Now listen to this one very carefully. This reaction is very, very important, right? So the reaction that we are learning today is very, very important. Okay. Now look at this one, students. We have an aldehyde like this, right? We have an aldehyde like this. So this is actually ethanol, right? This is ethanol aldehyde. So according to this aldehyde, remember, this is actually polarized. Carbon is delta plus, positively charged. Oxygen is delta minus, negatively charged. Delta plus and delta minus. Okay. And we are adding here diluted sodium hydroxide. Diluted aqueous sodium hydroxide. We can say that we are adding aqueous sodium hydroxide for this one. Okay. That means we can say that OH minus is added. Diluted aqueous sodium hydroxide means OH minus is. Now remember, students, this carbonyl group is polarized. Okay, that means oxygen is pulling electrons from the carbon atom. Then this carbon atom feel some kind of an electron deficiency in it. So therefore, that carbon atom, what that carbon atom will do is that carbon atom is asking electrons from the neighboring carbon atom in this, right? Then this neighboring carbon atom is taking electrons from hydrogen, right? This hydrogen. Try to understand. This is a carbonyl group. Carbon-oxygen bond is polarized. Oxygen is delta minus, carbon is delta plus. So oxygen is pulling electrons. So therefore, there will be an electron deficiency. There will be an electron deficiency around this carbon atom. And the neighboring carbon atom is also feel that electron deficiency. So therefore, this carbon atom is asking electrons from the other carbon atom. Then this carbon atom has to pull the electrons, take the electrons from the hydrogen atom. Then what will happen is carbon hydrogen bond is breaking. Carbon hydrogen bond is breaking by giving electrons for the carbon atom. Right? Carbon atom is taking the electrons from that carbon hydrogen bond. Now hydrogen is eliminating as what? Hydrogen is eliminating as H plus. Hydrogen is eliminating from this reaction as H plus. Right? Then what will happen? After that, remember students, after that, this OH minus is taking electrons. OH minus is taking that H plus removed by this carbon atom. Right? Right? The next thing that you have to remember, the nearest carbon atom, the neighboring carbon atom, the closest carbon atom for this carbonyl group is considered as alpha carbon, right? What is it? Alpha carbon. So the next carbon atom. So after this one, just imagine here we have another carbon atom that is known as beta carbon. So hydrogen atom which is connected to alpha carbon is known as alpha hydrogen. Okay, alpha hydrogen. Can you understand? Remember, when we add OH minus to the medium, carbonyl group is polarized, right? Oxygen is pulling electrons. So therefore, this carbon has to pull the electrons from the hydrogen. The bond is breaking. Carbon-hydrogen bond is breaking by giving electrons for the carbon atom. Then hydrogen has to eliminate from the compound. Then this hydrogen is taken by OH from the medium. Because in order to do the self-condensation reactions, we are adding diluted sodium hydroxide. Okay, diluted aqueous sodium hydroxide. Therefore, what will happen? This is known as alpha carbon, right? So always remember the nearest carbon atom, the next carbon atom for the carbonyl group carbon atom is known as alpha carbon. Always hydrogens are eliminating from this alpha carbon. Then students, a product is produced. That product is look like this, right? Now carbon has taken electrons. These are the electrons. Now this carbon is negatively charged in here. Now we know that OH minus connected to hydrogen. Now you can see that this is H2O, water molecule, right? Students, if I ask you a question, what kind of a reaction is this, as you think? As you think, what kind of a reaction is this? Can anyone tell me? Elimination. Okay, elimination is also okay. But rather than telling elimination, something else. Something else. Here. Rather than telling elimination. Something else you can say. When OH minus is taking H plus, what kind of a reaction is this? As a thing. When OH minus is taking H plus. So someone can say this is acid-base reaction, right? It doesn't matter. Why? OH minus is taking hydrogen from the aldehyde. So therefore, if someone say this is acid-base reaction, yeah, correct, right? In the MCQ paper, what about if they given like this? The first step of the self-condensation reaction can be considered as acid-base reaction. What is that wrong? That's correct. Look at the reaction mechanism, right? Now our topic is self-condensation, right? So self-condensation means the molecule itself connecting to it, right? So molecule is connecting to itself again. Now you can see that this is actually considered as a carbanion, right? What is this? This is known as carbanion. Carbon is having a negative charge, right? After removal of that hydrogen, this is a carbanion formed by that aldehyde. Do you know what is the next step? The very next step is the same aldehyde CH3C double bond OH, right? Aldehyde molecule is connected to this nucleophile, right? This is now considered as a nucleophile. We know that we have discussed about electrophiles and nucleophiles. Nucleophiles are the negatively charged species. So therefore, this negatively charged nucleophile or the carbanion is now attacking this aldehyde molecule, right? So that's why this is known as self-condensation. Right? The molecule itself is reacting, right? Then what will happen? This carbanion. Now look at this one. Carbanion is coming closer to this molecule C double bond H. Then what will happen? So this is, we know that this carbon oxygen bond is polarized, delta minus, and carbon is delta plus. So what will happen? This negatively charged carbon atom is connecting to this positively charged carbon atom in the other compound, right? Other compound. Try to understand. Okay. Now, remember, when this carbon atom is connected to this carbon atom, students, carbon cannot form 5 bonds. So therefore, one of the bonds has to be broken, right? So can you tell me in which bond there is a probability to break that bond? You can say that this double bond. This double bond is breaking by giving electrons for the oxygen. Then we can see that a product is produced in this way, CH3O. Now this oxygen atom is negatively charged, hydrogen here. Now this is the nucleophile. That nucleophile is connected to carbon atom to hydrogen C double bond H. And Can you understand? Now you can see that we have started from 2 carbon atoms. Now we have 4 carbon atoms in a row. Self-condensation. Self-condensation is carbon increasing reaction. Can you understand? Right? Then we know that water molecule is there in the medium. So what will happen is this oxygen is taking electrons from the hydrogen. This hydrogen has to give electrons from oxygen and producing molecules. Right? Right. Anyhow, this is the next reaction. That means the next step of this reaction. Okay. So the reason that I'm teaching you the reaction mechanism before go for the reaction discussion, I want you to understand what happened exactly. Then easily you can go for the answers. I'll give you what is the short method to go for the answers. Right? What are the self-condensation, how to obtain the self-condensation products.
The fast mode to speed.
But remember, you have to understand this. Okay, you have to understand this one. Okay, raise your hand who understood up to now. Quickly. Please mute your microphones. If you have any doubts, put your doubts in the chat box. Right. Now up to here is everything is okay, right? Now students, listen to this one again. Let me add here something like this. Now this hydrogen is connecting to this group. Okay. Then it is producing CH3, COH, H, CH2, C double bond OH. Right. This product, now look at the product. So this is the product by addition of sodium hydroxide, dial sodium hydroxide for aldehyde. This is the product that we will obtain. So there is an interesting name for this one. So as you can see that this is the aldehyde group, right? So then we are taking a part of the name ald. So OH group is representing alcohols, right? Then we can take all. Then this compound is known as aldol product. This is considered as aldol product. Okay. Ald from the aldehyde group, all from the alcohol group, then this is known as aldol product. If it is a ketone, ketol product. Can you understand? Aldol. That's why I told you sometimes this is considered as aldol condensation. Right? But if it is only for the aldehydes. If it is a ketone, we can say that ketol condensation. So commonly we can say self-condensation. Right? Self-condensation reactions of aldehydes and ketones. Can you understand? This is what happens. Okay. Now tell me, what kind of a reaction is this? Right? Is it nucleophilic addition, nucleophilic substitution, electrophilic addition, electrophilic substitution, elimination, acid-base reaction? What is this type? What happened first of all in this step? Right? In the very first step, we know that OH minus taken H plus is an acid-base reaction. So in the second step, what is it? Can you tell me? What is it? I told you that this carbon ion is acting as the nucleophile. Right? This is acting as the nucleophile. So if it is acting as the nucleophile, I can say that this is what? Nucleophilic addition reaction. Right? N type of a reaction. Nucleophilic addition reaction. Okay? Try to understand. Okay, come up to here quickly. And if you have any doubts, tell me. We have another step for this one. quickly write down this one. Put the arrows correctly. Put the charges correctly. Done it. Right. Now we have the aldol product, right? Remember, this aldol product easily can be dehydrate. Okay, this can be easily dehydrate. Now this is the aldol product. We have CH3, COH, H here, CH2, C double bond H. Okay, so I'm gonna add here H plus and heat, right? So when we add H plus and heat, this is actually a dehydration. So dehydration means we know that a water molecule is eliminating from the compound. OH group is there. According to the 8-step rule, we know that always hydrogen should be eliminated from the carbon atom who is connected to less number of hydrogen. So therefore, that's from here. Then the product is CH3, CH double bond CH, C double bond H. Right? Remember, students, this compound is known as, right? So yeah, we have a question like this. So as H plus from H2O is added, is that part an electrophilic addition? No. H plus is not added from water, right? Because the H plus amount that is given by water is actually a less amount, right? If I say that one in concentration, 1 into 10 to the power minus 7 moles per cubic decimeter, very low concentration. So therefore, we can't consider that, right? So here we are adding H plus to what? Some kind of accelerate the dehydration reaction. So therefore, when you heat this one, what will happen? H is eliminating with OH minus, then the product is okay. Okay. But you can see that still OH minus is in the medium, right? After taking this hydrogen, OH minus is in the medium. So therefore, OH minus is acting as a catalyst for this reaction. At the beginning, I started the reaction with OH minus, right? So along with this, I have OH minus. So this is actually, this is considered as a base catalyst self-condensation reaction. A base catalyst reaction. Can you understand? We are adding aqueous sodium hydroxide, base catalyst reaction. Sodium hydroxide is a base. Now look at the next product. After the dehydration, look at the product we have. So this is also aldehyde. But remember, this is actually unsaturated aldehyde. Because carbon-carbon double bond is there. Remember, students, these two carbon atoms are considered, as I told you, that the nearest carbon atom to this carbonyl carbon is known as alpha. The next one is beta. Then this is considered as alpha comma beta unsaturated. Alpha comma beta. Alpha comma beta unsaturated hydrocarbon. Right? Unsaturated aldehyde. Alpha comma beta unsaturated aldehyde. So after the dehydration, the product that we obtain is alpha beta unsaturated aldehyde. Keep that in your mind. Okay. Actually, these two are two steps. Okay. Addition of aqueous sodium hydroxide is giving this aldol product or ketol product. So after the dehydration only, we are obtaining this kind of alpha beta unsaturated aldehyde or ketone. Keep that in your mind. Those are two steps. So I'm going to discuss some examples with you. Then you will understand more. So this is actually elimination reaction, right? Elimination reaction, right? That means at the first step, we saw acid-base reaction. In the second step, we saw that nucleophilic addition reaction. Now we are seeing that elimination reaction. Right? Become a reaction types tunak, right? Reaction types tunak, we could see. Right, okay, are we done? Yeah. Now, students, what is the overall reaction? Shall we get that one as a summary? Overall reaction. Look at this one. So H plus added to O minus to form the aldol product, right? So do we consider it as electrophilic addition? No, 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 it's not electrophilic addition. Okay. So it's not the actually H plus was taken by oxygen. That's all. It's not an electrophilic addition, right? Because we didn't put water molecule as a region for the reaction medium. Okay? So in the first step, we saw that water molecule is produced. From that water molecule, a hydrogen is taken by the intermediate product, right? So therefore, we didn't add a region like water. So therefore, we can't consider that is what? Electrophilic addition. Can you understand? Right. Now, summary of the reaction. What happened exactly? We had ethanol, CH3, C double bond OH. So we had aqueous sodium hydroxide. Then it is producing CH3, COH, H, CH2, C double bond OH. Right. I'll tell you how to obtain this one directly. And when we add H plus heat, this is producing alpha comma beta unsaturated aldehyde. So this is the summary. This is what happened, right? So these are two steps. This is what happened. Okay. We can say that actually two methanol molecules. Two ethanol molecules. Right. Write down this one as a summary quickly. Right. Okay. Let's see how we can obtain the products easily. Done. Okay, students. Now listen to this one. Look at this one very carefully. Let me take the previous example again. CH3, C double bond OH, ethanol. Ethanol molecule that we had, right? So it is reacting with the same molecule, CH3, C double bond OH, right? So we know that what happened actually. So this is the alpha carbon, right? This is the alpha carbon, right? Carbon atom, which is close to the carbonyl group carbon atom. So that is known as alpha carbon. So we know that this carbon has to connect for this carbon in the carbonyl carbon in the other compound, right? Then this carbon oxygen bond is breaking. Oxygen is taking this hydrogen. Look at this one. Again, look at this. Start from the carbonyl carbon. Carbonyl carbon is ready to remove hydrogen. So it is removing hydrogen. Then this carbon is connecting to the carbonyl carbon in the other molecule. Then carbon-oxygen double bond has to be broken. Then oxygen is taking this removed hydrogen. Then what is the product? We can say that the product is CH3C. Oxygen took that hydrogen, therefore OH, H here. Then here we know that now this hydrogen is not there anymore. Then CH2, right? We can say CH2, C double bond OH is the product, aldol product. So after addition of H plus and heat, what will happen? This OH is eliminating with the hydrogen from the nearest carbon atom, which is having the less number of hydrogen. Say it's a fruit. Then it is producing CH3, CH double bond CH, C double bond OH. This kind of a product. Right? Can you understand? Can you understand what happened? Raise your hand who understood this one. Don't worry. I'm going to simplify this one even further. Don't worry. Try to understand little by little. Let's reduce the strength of this one. Right. Now, let me consider the second example, propanol. CH3, CH2, C double bond OH. Now look at this one, right? Now let me consider the propanol molecule CH3, CH2, C double bond OH in this way. Now I'll spread the bonds and let me write down the compound propanol in this way. Students, now you have to carefully choose the alpha carbon atom, right? Because beta carbon atom is also there. Alpha, this is beta. I told you that alpha carbon atom is the nearest one, the closest one for the carbonyl group carbon. So therefore we can say that this is the alpha carbon atom, right? Then hydrogen should eliminate from that carbon atom, right? Keep that in your mind. Hydrogen should eliminate from that carbon atom. Now this carbon atom is connecting to this other molecules carbonyl carbon atom. Carbon oxygen double bond is breaking. Oxygen is taking that alpha hydrogen. That's what happened. Then the product should be CH3, CH2, OH here. So now we know that this is the carbon atom connecting there, right? Be careful. Don't connect this beta carbon atom for this one. Because for the beta carbon atom, already octet is satisfied. So you can't connect that carbon atom for this carbon. So you have to be very careful here. Now this is the hydrogen removed. So there is a space. That space only going to fill by this carbon-carbon double bond. And then this is the carbon atom is going there. That carbon atom is already connected to three groups. Hydrogen, CH3 methyl group is there, and aldehyde group. So I can mention that one H here. So let me write down that methyl group here in this way. Now, okay, C double bond H, right? That's all. Can you understand? So when we put H plus, and I'm going to heap this one, OH is eliminating. So where is the nearest carbon atom? Neighboring carbon atom, this one or this one? Hydrogen should eliminate from the carbon atom who is rich, poor with hydrogen. This one. Product should be CH3, CH2, CH double bond, CH3, C double bond OH. Carefully go through that one. And if you have any doubts, let me know. Then you can choose any carbon atom. Pranali, if it is a ketone, so the next example is actually ketone. There you will see. You can choose any carbon. No worries. No, it's okay, fine. You can ask questions. Don't think like that. You have to ask questions, and I'm also ready to answer for your questions. Okay, it's okay, totally fine. Right, okay. Shall we move to the next example? Shall we move to the next example? Example number 3. Yeah. So look at the third example here. So third example is actually acetone, CH3, C double bond or CH3 in this way. So we can spread the bonds in this way. Now remember, students, both the alpha carbon atoms. Now here we can see that here there are two carbon atoms, right? There are two carbon atoms. These are two neighboring carbon atoms. So both the alpha carbon atoms. So you can choose one of the carbon atoms. They are arbitrary, isn't that? Right? So what will happen as we discuss? This is the alpha carbon. Hydrogen is eliminating. That carbon is connecting to this one. Carbon oxygen bond is broken. Oxygen is taking that alpha hydrogen. Then the product should be CH3, COH, CH3 here. Now this hydrogen eliminated, remaining things are CH2, C double bond to CH2. Now this is not aldol product, this is ketone product. Can you understand? This is considered as a ketone product. So after addition of H plus and E, what will happen? OH is eliminating with one of the hydrogens, right? So from the poor number of hydrogen containing carbon atom, CH3, CH3 double bond CH, CH3. Right. Okay. So this is alpha beta unsaturated ketone. Alpha beta unsaturated ketone. Quickly come to this one. Right, okay, are we done? Yeah. Now listen to this one, students. Now look at this one. Now look at this one very carefully. Even a shorter method. So we have ethanol molecule, two ethanol molecules. We are adding 8 plus sodium hydroxide. Now you are asked to produce the, you are asked to get the product directly. Directly gun again. How do you take that? It's very simple. Huh? Look at this one. Let me take this carbon hydrogen bond down. I can change this carbonyl group oxygen as OH. Okay, that's what we have to do first. What we have done, I took the CH3 C group here. I took this carbon hydrogen bond down. And I changed this carbonyl group C double bond O into COH in this. And the next thing is go for the alpha carbon. Remove one hydrogen from alpha carbon and connect the remaining things here from the carbon atom, from the alpha carbon atom. What did I say? Remove one hydrogen from the alpha carbon and now connect the alpha carbon for this carbon atom. After removal of hydrogen from this carbon, what we obtain? CH2 and then CH2 C double bond H. This is the easiest method that we can write down the product. Raise your hand, those who understood that. Quickly raise your hand, those who understood that method. If you have any doubts, tell me. Do I need to explain that one again? Right? One last time. Huh? One last time. Look at this one. What we have to do? Write down this CH3 group in this way. And I'm going to take this carbon hydrogen bond down. CH. You can convert this carbonyl group all the time as COH. Now go for the alpha carbon. Remove one hydrogen. Remove alpha hydrogen from the alpha carbon. Then the remaining things should be connected with the carbon atom here. After removal of alpha hydrogen there, CH2 is the remaining group. C double bond OH. That's all. Easy. Can you understand? Right? Very easy. Now let's go for the second example that we discussed. Second example was CH3CH2 C double bond H propanol. I'm going to add aqueous sodium hydroxide. I'm going to add aqueous sodium hydroxide. Right? So when I'm adding aqueous sodium hydroxide, look at this one. Okay. What did I tell you? Put the carbon hydrogen bond down. Convert this group into COH. Choose the alpha carbon. This is the alpha carbon. No? This is the alpha carbon. After removal of one hydrogen from the alpha carbon, connect that carbon atom for this one. Connect that carbon atom. Hydrogen is there for that carbon. CH3 group is there for that carbon. C double bond H. Can you understand? This is the second part. Now let's move to the third example that we discussed. Acetone CH3 C double bond CH3. I'm going to add here aqueous sodium hydroxide. Aqueous sodium hydroxide. So what will happen is CH3 C, I told you that is OH group. You can put this bond down. CH. Then go for the carbonyl carbon. Remove one hydrogen there. Then the remaining things should be connected with that carbon atom to this carbon. After removal of hydrogen, CH2, CH2 C double bond CH3. Can you understand? Right? So this is the direct method that we can obtain the answers. Right? Raise your hand, those who understood those examples, those three examples again. If you have any doubts, tell me. Doesn't matter. Right? Sure. Now we are going to write some products of this aldol self-condensation reactions, right? So hereafter, after adding H plus and heat, you know what is happening. So that's very easy. OH is a limit H. So here also we can say that hydrogen is eliminated with this one. Like this. Okay. I hope that you can understand to write the products of condensation reactions. Right, okay, are we done? Let's move to the fourth one. Get the products of this reaction. So is it necessary to put 2 in front of everything like in the first one? It's not compulsory. So the reason that I have added that one, because in your resource book they have given 2. If it is the same molecule, put 2 there, because you can show that 2 molecules are 2 molecules, 2 same type of molecules, right? Because now after some examples we are going to discuss that 2 different molecules are also real, right? So 2 different aldehydes are also connected, right? Because some of the aldehydes are there, they do not contain not only aldehyde, ketones also there. They are not containing alpha carbon or alpha hydrogen, but alpha hydrogen is not there. So in that case, what will happen, right? So we are going to see that one. Okay, wait. Now, before that, go for this one, fourth one. Now you should be able to get the products directly. Yeah. Let me consider CH3 double bondo, and here we have benzene ring. Okay, benzene ring. Then I'm going to add here aqueous sodium hydroxide. Write down the products quick. Fourth one, and number 5, fifth one. So it's like this. It's a ketone. So fourth one, fifth one, they are ketones. Get the product directly. Now you should be able to get the products directly. Number 6. Raise your hand those who got the answers for 4, 5, 6 correctly. Now. Right. Now look at this one. Huh? As we discussed, CH3, you can convert carbonyl group into OH and put the benzene ring down. And remove one hydrogen from this CH3 group, then CH2, C double bond O, benzene ring. Okay. Next one. If I give you this is number 1 and number 2 is H plus and heat, what will happen? Then OH is eliminating with hydrogen, then it is producing. Can you understand? Right? Number 1 and number 2. Then you can directly obtain this product. Number 5. So, right. Now tell me, what is the alpha carbon here? Left hand side one or right hand side one? What is the alpha carbon? What do you think? Right. Why it is? Students, I told you that both of them are alpha carbons, right? This one, both are alpha carbons. So, interestingly, here you can obtain two products like this. Look at this one. CH3, COH, CH2, CH3. So I can say that hydrogen is eliminating from here. Then the product is CH2. C double bond O, CH2, CH2. And we have another product. What is the other product? I could say that hydrogen is eliminating from the other alpha carbon. CH3, OH, CH2, CH3. I'm going to consider that hydrogen is eliminated from this carbon atom. Then this carbon atom is only connecting here. As after removal of that one, CH3 is there, hydrogen is there. C double bond or CH3 group is removed in this way. Right? So let me show this one as C2H5. Right? This is also one of the alpha carbons. Alpha carbon. Both are considered. So therefore, there are two products that we can obtain. Right? So raise your hand, those who got both the answers. Anyone here? Raise your hand, those who got these two answers at once. Nabil, okay, very good. Ifad, okay, very good. Good. So you can write down both the products. Huh? What about the sixth one? How about the sixth one? So I can say that in the sixth one, CH3, hydrogen. So we can take this is OH and hydrogen can be taken down here. Right? And this is the alpha carbon and alpha hydrogen can be eliminated. Then CH3, CH3, C double bond H in this way. Okay. Now in case, if you are given that sodium hydroxide 8% H plus heat, then what will happen? How we can say? Remember, OH should be eliminated from the neighboring carbon atoms, hydrogen. So you can see that this carbon atom doesn't contain any hydrogens. So therefore, this carbon atom has to choose the left-hand side carbon. Then it is producing double bond like this. So this is the product that we obtain after addition of H plus N. Number 6 should be like this. Okay. Try to understand what is happening here. If you have any doubts, put your doubts in the chat box. Now I'm going to teach you another thing, another new thing. Many students say that this reaction is difficult. Yeah, honestly, it is difficult. But remember, by taking some time, by practicing these things, that difficulty is actually converted into an easy task, right? It's not a difficult thing if you practice this one continuously, okay? Because many students actually easily forget these things. What is the method? And right, okay. Now tell me, students, now I need the answers from all of you. Can this aldehyde, this is methanol, two methanol molecules, can two methanol molecules undergo self-condensation reaction? Can two methanol molecule undergo self-condensation? Yes, Sarina, correct. What about the others? What is your opinion? Can two methanol molecules undergo self-condensation reaction? Yes. Yes. The answer and the reason also correct. Right? Remember, students, where is the alpha carbon? Right? Do we have alpha carbon here? So when we had sodium hydroxide aqueous, so in order to do the self-condensation reaction, so where is the alpha carbon? We can't remove the hydrogens from this carbonyl carbon. So there won't be any reaction. So that means that methanol molecule is not undergoing self-condensation reaction anytime. No chance, zero chance. Remember, students, there is a condition. If methanol molecule want to undergo self-condensation reaction, that methanol molecule should be connected to another aldehyde ketone, which is having alpha carbon with alpha hydrogen. Right? Now, for an example like this, just imagine we have methanol and ethanol both, right? In a reaction medium, methanol and ethanol both are added. And now there is a chance to form aldol product. Now there is a chance to undergo aldol condensation reaction, right? How? Remember, when we had aqueous sodium hydroxide, so it's true that we know that this molecule doesn't have any alpha carbon or alpha hydrogen, but in ethanol, we can see alpha carbon and alpha hydrogen nicely, right? So therefore, what we have to do is you can start to do the reaction in this way. First of all, as before, what I'm going to do is I'm going to put this carbon hydrogen bond down. You can convert that one into OH, right? In the next step only, we need the alpha carbon and alpha hydrogen. So where is the alpha carbon? This is the alpha carbon. So one of the hydrogens connected to this carbon atom is alpha hydrogen. Remove that hydrogen. Then what is the remaining things? CH2. Connect that one for this carbon. C double bond H. Right? So this is also what? Aldol product. Aldol product. After addition of H plus heat, what will happen? OH is eliminating with the hydrogen in heat. Right? Can you understand? Let me write down that product also. When we add H plus heat, what will happen? OH is eliminating with hydrogen from the neighboring carbon atom. So the only neighboring carbon atom is this one. So therefore CH2, double bond CH, double bond OH. Final product. Can you understand? Remember, two methanol molecules cannot undergo self-condensation reaction because of not having alpha carbon or alpha hydrogen. Then what this methanol molecule will do is, to do a self-condensation reaction, to do a condensation reaction, is choosing another aldehyde or ketone which is having alpha carbon with alpha hydrogen. Right? Then it can undergo self-condensation reaction like this. Right? So the ninth one is also very interesting. Look at this one, will you? So this is also interesting. Students, we know that there is an aldehyde like benzaldehyde. Benzaldehyde. Right? Benzaldehyde. What do you think? Now here you might think that, sir, anyhow in the benzene ring we have carbon. Eh? Yeah, alpha carbon is there, but where is the alpha hydrogen? No, right? So this carbon doesn't have any hydrogens. You know that only these portions only having hydrogens. So therefore alpha carbon is there, but alpha hydrogen is missing in this compound. Then will there be any self-condensation reaction, condensation reaction? Alone, right? So two molecules are connected. No, by addition of aqueous sodium hydroxide, nothing will happen, no reaction. Okay? Nothing will happen, no reaction. Can you understand? Then, so I'll do the reaction like this again. 10th one, I'm gonna do the condensation reaction for benzaldehyde with another aldehyde like, let me choose the ethanol again, CH3C double bond OH. Then there is a chance, right? Then there is a chance to do the self-condensation. Now we can say self-condensation. Now we have to say that hereafter just condensation, aldol condensation, right? Self-condensation means that molecule is connecting to itself. Now for this reaction, number 8, number 9, they are not self-condensation. They are aldol condensation or just condensation reactions, right? And now benzene ring is taken, OH here, H here. So this is the alpha carbon, remove alpha hydrogen, then CH2, C double bond OH. It is. So when we add H plus heat, what will happen? OH is eliminating with the nearest carbon atom's hydrogen and producing alpha beta unsaturated aldehyde. Right? So you have to understand this. Okay. Remember, students, many conversions are there. Many conversions are there. Done, eh? Right. Yeah. Now look at this one. How about this kind of a compound? Number 11. Students, will there be any condensation reaction? Will there be any self-condensation reaction for this? What do you think? No. Yeah, what is the reason? No alpha hydrogen. Yes. Alpha carbon is there. Where is the alpha hydrogen? No alpha hydrogen. So therefore, no reaction. So this kind of a compound can let react with ethanol kind of molecules to get the products. Sodium hydroxide aqueous is added. CH3, OH, and put the carbon hydrogen bond down. Now CH2, C double bond OH can be connected. That's all very easy. Okay. So after that, we can add H plus H2O. Then we can have this kind of a product, right? Okay, so this is all about the self-condensation reactions, right? Nothing more. Right, okay. Now I'm going to give you a question. Answer for this one quickly. I need the answers. Question. a mixture of a mixture of ethanol and propanol is given. Write all the possible, write all the possible condensation products, condensation products in the mixture, in the mixture. Right. Quickly start. You are given ethanol and propanol mixture. They are asking write all the possible condensation products in this mixture. Right. What is the answer? Right. Okay. Wait. Before do that one, tell me how many products that you can obtain maximum. How many products that you can obtain maximum? As you think. Anyone here? From the ethanol and propanol mixture, how many products that you can obtain maximum? Can't you directly tell them? No, Pranal. No. It's not the answer. Yeah, Gimani correct. Gimani, you are correct. Yes. What about the others? Students, there will be 4 products. May ethanol connecting to ethanol, propanol connecting to propanol, ethanol connecting to propanol, propanol connecting to ethanol. 4 products are there. 4 products are there. Now write down the answers. Ethanol, ethanol, propanol, propanol, ethanol, propanol, propanol, ethanol. Now you can get the answers quickly. 4 different products are there. So we can write down the products. Number 1, ethanol with ethanol. So we are adding sodium hydroxide aqueous, okay? Number 2, propanol and propanol. Then we have CH3, CH2, COH, H here. So here we have to choose alpha carbon. So this is the alpha carbon, right? From that, remove hydrogen and connect that one for the carbon atom here. Right? So what is the third one? Third one is ethanol and propanol. Number 3, ethanol and propanol. One of the hydrogen removed from this alpha carbon, right? C double bond OH. Then you can exchange them. propanol and ethanol. Then what is the product? CH3CH2, COHH, CH2, C double bond OH. Right? That's all. Right, okay. Are we done? If you have any doubts, tell me. So don't we need to write down elimination reaction? No need, because they haven't given that they are going to dehydrate this one. They have added methanol and ethanol and added sodium hydroxide. Okay? So you can write down the products if you want, doesn't matter. Okay? Right, okay. Then students, in today's class, we discuss about very, very, very important reaction. Right? I think this is the most important reaction. We can say that because many students are telling that this is difficult, so therefore this should be very important. So what you have to do is again practice these reactions that we discussed today. Okay. So after the class, I'll send you some exercises. So do that one. So small conversions to practice these conversions. How the conversions are coming under the carbon increasing reaction number 9, self-condensation reactions. Right? Raise your hand those who understood the self-condensation reaction that we discussed today. Do you have any doubts here? Anything? Okay. Right. Then I'll upload the questions. If you are staying, if you are awake until midnight, morning, so you can do the conversions and send. Right? Okay. So then I'm going to wind up the session. So let's meet in the next session. Okay. Right. Bye bye. Have fun. Good night for all of you.